Timeless concepts from Physics Helpline. In this video tutorial, we will discuss 3 multiple choice questions taken from the NEET exam of 2019. The questions are as follows. Question 1. It is about a solid cylinder of mass 2 kg and radius 50 centimeters. This cylinder rolls up an inclined plane whose angle of inclination is given as 30 degrees. Initially, the center of mass of the cylinder has a speed of 4 meters per second. The acceleration due to gravity is given as g is equal to 10 meters per second square. We are required to find the distance traveled by the cylinder on the inclined plane. The options are given in the question. We are required to find the correct option. Now for the answer. The situation is shown in the figure. A is the initial position of the cylinder and C is its final position, where its height BC is equal to h. And in the process, it travels from A to C, traveling a distance of x. Initially at A, it has got a speed of 4 meters per second. Now, when mass is equal to m and radius is equal to r, translational kinetic energy kT is equal to half mv square, where v is the speed of the cylinder. And rotational kinetic energy kr is equal to half I omega square, where I is the moment of inertia and omega is the angular velocity. Now half, which is equal to half into I is equal to half mr square and omega square is equal to v square by r square. Therefore, kr is equal to half into half mv square, because r square and r square gets cancelled. Therefore, total kinetic energy K is equal to kT plus kr. Adding these two, half mv square is common for both. So K is equal to half mv square into 1 plus 1 by 2. So 1 plus 1 by 2 is 3 by 2. Half of 3 by 2, half mv square into 3 by 2 will give us K is equal to 3 by 4 mv square. Now at position C, its height from the ground level is equal to h. Therefore, potential energy at the highest point C is given by U is equal to mgh. From equations 3 and 4 we get 3 by 4 mv square is equal to mgh. Now m and m gets cancelled, gives us h is equal to 3v square by 4g. It's given that v is equal to 4 meters per second. Therefore, 3 into 4 square divided by 4 into 10, which on simplification gives h is equal to 1.2 meters. From the right angle triangle ABC, we have got h by x. BC divided by AC, h by x is equal to sin 30, which is equal to 1 by 2, which gives x is equal to 2h, which is equal to 2.4 meters, which is the answer to question 1. Therefore, the correct option is A. Now, for question 2, this is about an object whose mass is given as 500 grams. It is initially at rest. It is acted upon by a force in the x direction. The magnitude of the force varies with x as shown in the figure. We are required to find the velocities of the body at x is equal to 8 meters and x is equal to 12 meters. The options are given in the question. We are required to find the correct option. Now for the answer. Now we'll use the concept that area under the force and displacement graph gives us the total work done during that displacement. So we are required to find the velocity of the particle at x is equal to 8 meters and x is equal to 12 meters. For that we will need the work done from x is equal to 0 to 8 and x is equal to 0 to 12. First, we will calculate the work done from x is equal to 0 to x is equal to 8 meters. We denote it by W08. Now 0 to 8 comprises of two parts, 0 to 5 meters, where the force is 20 newtons, and from 5 to 8 meters the force is 10 newtons. Therefore, W0 to 8 is equal to 20 into 5 plus 10 into 3, which gives us 100 plus 30 is equal to 130 joules. Now we will apply the work energy theorem. That means kinetic energy is equal to the total work done during the process. If V8 is the velocity at x is equal to 8 meters, then the kinetic energy half mv8 square is equal to W08, which gives half into m. M is 500 grams, therefore half kg into V8 square is equal to 130. So V8 square will be equal to 130 into 4, that is 520. Therefore V8 is equal to root over 520, which is equal to 22.8 meters per second, which is nearly equal to 23 meters per second. Now we want to calculate the work done from x is equal to 0 to 12 meters. This happens in 1, 2, 3 and 4 parts. Up to 8, x is equal to 8 meters, that we have already calculated. W0 to 8 we have already calculated as equal to 130 joules. Rest we will calculate work done from 8 to 10 and work done from 10 to 12. Now we observe that between x is equal to 8 to 10, the graph is below the x-axis. Therefore, the forces are negative. Therefore, the work done will be negative. Therefore, for 8 to 10, it comprises of two parts, one a rectangle and another a triangle. For the rectangle, the width is 2 meters and the height is 22.5 newtons. So, we have got 22.5 into 2 with a negative sign outside. And for the triangle, half into B into H. B is 2 meters and H is equal to 2.5 newtons. So half into 2 into 2.5. Half and 2 gets cancelled, giving us 2.5. Therefore, we get minus of 45 plus 2.5 joules, which is equal to minus 47.5 joules. Again, from x is equal to 10 to 12, W 10 to 12, work done will be equal to, the force in this case is 10 newtons and the displacement is 2, which gives us 20 joules. Therefore, work done from 0 to 12 meters is equal to 130 minus 47.5 plus 20, which is equal to 102.5 joules. Now, if B12 is the velocity of the particle at x is equal to 12 meters, then its kinetic energy will be equal to half mv12 square, which should be equal to W012. Therefore, half into m is again half into v12 square is equal to 102.5 joules. Therefore, v12 square is equal to 102.5 into 4, which will be equal to 410. Therefore, V12 is equal to root over 410, which is equal to 20.6 meters per second. Therefore, V8 and V12 will be equal to 23 meters per second and 20.6 meters per second, which is the answer to question 2. Therefore, the correct option is D. Now for question 3. It is about a particle of mass 5m initially at rest. This breaks on its own into 3 parts. 2 parts of mass m each move along mutually perpendicular directions with speed equal to v each. we are required to find the energy released in the process. The options are given in the question. We are required to find the correct option. Now for the answer. The situation is shown in the figure. This is the particle of mass 5m. It breaks into three parts. Part A of mass m, part B again of mass m, and part C is 3m. It is given that A and B both move with speed v in mutually perpendicular directions. So we denote VA as the velocity of A and VB as the velocity of B. They are along x and y directions respectively. So VA is equal to V and VB is equal to V. And let the velocity of C will be equal to Vc. Now, particle is initially at rest. Therefore, its linear momentum initially Pi is equal to 0 and kinetic energy is also equal to 0. Finally, we have got VA is equal to Vi cap because A is moving in the x direction, and VB is equal to Vj cap because it is moving in the y direction. Therefore, the final linear momentum Pf will be equal to m into Vi cap plus m into Vj cap plus 3m into Vc, because this is for A and this is for B and this is for C. So conservation of momentum gives Pi is equal to Pf, which gives mvi cap plus mvj cap is equal to 3mvc will be equal to 0. Therefore, Vc, m gets cancelled throughout, so Vc will be equal to minus 1 by 3 into Vi plus Vj. Which is equal to minus V by 3 into I plus J, I cap plus J cap. Now the magnitude of Bc will be equal to, because V by 3 that we are keeping, and the magnitude of I plus J, because I is equal to 1 and J is also equal to 1. Therefore, the magnitude of I plus J will be root over 1 plus 1 square plus 1 square, which will be equal to root 2. Therefore, magnitude of Vc will be equal to root 2 by 3V. Therefore, final kinetic energy Kf is equal to half mVa square plus half mVb square plus half 3mVc square, which is equal to half mv square, because Va is equal to V and Vb is also equal to V. Therefore, for this also we have got half mv square, and Vc square, Vc is equal to root 2 by 3 V. Therefore, Vc square will be 2 by 9 V square. So, half into 3m, mass of C is 3m into 2 by 9 V square, which will be equal to half mv square plus half mv square will be equal to mv square plus 1 by 3, because this 2 and 2 gets cancelled and 3 and 9 gives 1 by 3. So, 1 by 3 mv square. Therefore, Kf is equal to final kinetic energy will be equal to 4 by 3 mv square. Now, initial kinetic energy is 0 and final kinetic energy is 4 by 3 mv square. Therefore, change in kinetic energy delta K is equal to Kf minus Ki, which is equal to 4 by 3 mv square minus 0. Therefore, the energy released delta K will be equal to 4 by 3 mv square, which is the answer to question 3. Therefore, the correct option is A. This completes the answers to all the questions in this video tutorial. Thanks for watching. If the video is helpful, then please like, share and subscribe.